Everybody, chapter 1, section 6B. We're doing it in 2 parts. We're going to do the first part today. We're going to do the second part on Friday. If you're not here on Friday for whatever reason, you are responsible to watch the video and to complete the homework. Yes. We have the PSAT. Actually, I want to go over these real quick. Do you see these ones that I just wrote here? These are 2 problems from the 1.6a homework that some people who attempted it over the weekend emailed me and asked me questions about. All right. Oh, this should be cubed, not squared. Sorry. That's a 3. Hold on. Let's pretend that's a 3. All right. A lot of people, don't write down what I'm about to do. A lot of people that sent me an email said, hey, I'm confused on this. It's different versions, but similar to this question. They moved the 216 over, like so. Took the cube root, right? What's the cube root of 216? Negative 216. Negative 6, okay. And they put that in WebAssign, and WebAssign marked it wrong. Guys, how many answers should you have for this problem? 3. When you solve like that, when you should always try to factor first, when you solve like that, you're only going to find the real answers. If there's anything imaginary in there, it's going to be hidden inside. So you have to look at this and say, let me factor this. What do you guys notice about x cubed and 216? They're both perfect cubes. So this is a equals x. This is b equals 6. So your perfect cube pattern is x plus 6, and then what? X squared minus 6x plus 36. Yep. Whoops. Not 364 equals 0. So this right here is where you get your x equals negative 6, your real answer. Can you factor this? No. You cannot factor that. So you have to use the quadratic formula. And Caputi, what happens when you use the quadratic formula here? You get your imaginary solutions. There's 2 imaginaries hidden in here. Another question that came up, x to the 4th minus 81. You guys were telling me it's plus or minus 9. Factor x to the 4th minus 81. What does that factor to? X squared minus 9 and x squared what? Plus 9. Right here, there's 2 real answers. Your 2 real answers there are x equals plus or minus 3. Here, there's 2, how many, what kind of answers? Imaginary. If I move x squared plus 9, if I move 9 over, it becomes negative. Then when I take the square root, this is x equals plus or minus 3i. The highest exponent tells you how many answers you have. You have to remember that, guys. Same thing on this one. What's the highest exponent you see? 6. There's 6 answers to this question. You can factor this. What times what gives you x to the 6th? X cubed and x cubed. What are the factors of negative 8 that multiply to give you negative 8 but add to give you 7? Plus 8 minus 1. You guys agree? Both of these are what? So you can factor both of those. X plus 2, and then x squared minus 2x plus, right? You've got to be, those factoring things that we talked about, that you guys learned in Algebra 1, that we talked about at the beginning of Algebra 2, they're going to keep reoccurring. You cannot just be like, oh, I forgot that. That doesn't happen. It's going to be reoccurring. So some of you that struggled on the 1.6, go back and do it again. I'm not super concerned about your WebAssign score. I'm more concerned that come test time, you guys know how to do this. Yeah. All right, let's move. These 2 problems belong to the first part of 1.6b. We're going to solve radical equations, okay? The first couple examples are pretty simple. They're very straightforward. But at the end of the day, what you're trying to do is isolate one square root. Isolate means get it by itself. You would then want to square both sides of the equation to get the square root to go away. You solve, and then what does the last thing say right here? Check. It is imperative that you check. Some of the solutions, both of them will work. Sometimes the solutions, none of them will work. Sometimes only one. You have to check every one. I know it seems like a pain, but you guys need to do it, okay? So let's go through some examples here. Numbers 1 and 2 are very similar. Fix number 2. The square root should only be over 18. 1 and 2 are very similar. 1 and 2 are very similar. The first thing I'm going to tell you guys to do is, how many square roots do you see? How many square roots do you guys see? In number 1, how many radicals do you see? You see 2 square roots? There's 1. There's just 1 square root. We want to get it by itself. That is our goal. You can either move the x over or you can move the radical over. It doesn't matter. I'm going to take this radical and just move it over here. Can I do that? It's negative right now. So when I move it over there, it becomes what? Okay. So I'm going to rewrite this as x equals the square root of 15 minus 2x. If you did it the other way, that's fine. You would have subtracted x, then divided by -1. It's fine. But my goal at the beginning, I told you, is to isolate the radical. Is your radical now completely by itself? Yes. So then how do we undo it? You square both sides. So I'm going to square here, and I'm going to square here. So this becomes x squared equals, what happens when you square a square root? It cancels. So 15 minus 2x. Everybody with me? All right, so now I have a quadratic. So x squared, I'm going to move the 2x and the 15 over. So plus 2x minus 15 equals 0. And then at this point, we have a quadratic. We can complete the square, quadratic formula, but what should we always try to do first? You should always try to factor. So let's go ahead and factor this. What's the factors of negative 15 that multiply to give you negative 15 and add to give you 2? What kind of 5? What kind of 3?
Plus 5 minus 3.
Okay. So plus 5 and minus 3. So what are your 2x values? X equals -5 and x equals +3. Now we absolutely have to check. However you guys do the check is fine. Some of you want to do it in your head. That's fine. Some of you want to actually write it out. I don't have to see the check. You just have to make sure that you check. So I'm going to try -5. So -5 minus 15 minus 2 times -5. Does that give me 0? So -5 minus the square root of 15 plus 10 equals 0. -5 minus the square root of 25 equals 0. -5 minus 5 equals 0. Is that true? Does -5 minus 5 equal 0? No. So what do you know about x equals -5? It doesn't work. Be careful here with signs. Some of you will get here and go, oh yeah, it does work, because you're not paying attention to signs. So just be careful. This one does not work. So let's throw 3 in real quick. So I have 3 minus 15 minus 2 times 3. Does that equal 0? 3 minus, what's 15 minus 6? Okay, what's the square root of 9? 3 minus 3 equals 0? So we're good. But you have to check. Every single one you got to check. All right, number 2 is set up the exact same way. How many radicals do you guys see? There's just 1. Okay, we're going to come to a situation when we have more than 1. But we have just 1. So I want to circle it so I remind myself, hey, I need to get that by itself. So there's 2 things you can do. You can either subtract the x and divide by -1, or do you want to just move this one over here? Okay. So x equals, and when I move that over, it becomes positive. So 3x plus 18 is my radical all by itself. Yes or no? Yeah. There's nothing being multiplied or divided or added or subtracted to it. So what can I do now? Square both sides. Perfect. So x squared equals 3x plus 18. Excuse me. And we have another quadratic, yeah? X squared minus 3x minus 18 equals 0. What are the factors of -18 that multiply to give me -18 and add to give me -3? Perfect. Minus 6 plus 3. Good. So your 2 answers are x equals 6 and x equals -3. And I have to do what, guys? We got to check. So I'm going to do 6 minus the square root of 3 times 6 plus 18 Does that equal 0? What's 3 times 6? 18. What's 18 plus 18? Okay, so 6 minus 6 equals 0. Okay, we're good. Now let's throw in negative 3. So negative 3 minus 3 times negative 3 plus 18 equals 0. Negative 3 minus, what's 3 times negative 3? Negative 9 plus 18. Negative 9 plus 18. Positive 9, right? So you have negative 3 minus 3 equals 0. Is that true? No. So this one doesn't work. You guys are going to say to me, is it always 1 that doesn't work? No. That's not always the case, so be careful. All right, let's look at number 3. How many radicals do you see? 1. So I'm going to circle it because I want to get it by itself. Well, what do you notice? It's already by itself. So what are we going to do to both sides, guys? Okay, watch how I do this. I put this side in parentheses and I square it. I put this side in parentheses and I square it. So on the left-hand side, when you square a square root, this just cancels, yeah? So 4x plus 13 equals, what does 2x minus 1 quantity squared look like? 2x minus 1, perfect, times 2x minus 1. Don't try to skip that step and do it in your head and FOIL it all together. Write it out so you see it. Just to try to clear up those little mistakes. So just leave your 4x plus 13 over here. And now we're going to FOIL. What's 2x times 2x? 4x squared, good. If I multiply 2x times negative 1 and then negative 1 times 2x, what do I get? Negative 4x, good. And then negative 1 times negative 1? Plus 1, okay. Now we're back to the same place we were. Every single time, you guys are always going to arrive after the first or second step, we're going to be in the same spot. We're going to be at a quadratic, move everything to one side, and factor. So let's subtract 4x from both sides and subtract 13. So 4x squared minus 8x minus 12 equals 0. Quadratic formula, completing the square, all that good stuff. What's the first thing you should try? Try to factor it. What can I take out of all 3 of these? All right, so let's factor out that 4. I'm left with x squared minus 2x minus 3 equals 0. Can I factor that? To what? Yes, sir. X minus 3x plus 1. And then we set each piece equal to 0. So 4 equals 0. Ever true? No, don't worry about it. X minus 3 equals 0. So x equals positive 3. And here x equals negative 1. Correct? And what shall we do? Check. Check, check, check. Again, it doesn't have to be a formal check. You don't have to write it down and all that stuff, but something. Put it in, do it in your head, whatever you need to do, but just make sure you check. I like to write it out just so I don't miss a sign. So 4 times 3, 12. 12 plus 13. Okay, so square root 25 over here, and then 6 minus 1 is 5. What's the square root of 25? 5. Does 5 equal 5? All right, so 3 is good, valid. We like it. Let's do negative 1. So I have the square root of 4 times negative 1 plus 13 equals 2 times negative 1 minus 1. 4 times negative 1 is negative 4, and 13 is 9, right? What is the square root of 9? It's 3. If it was x squared and then you put the square root on, then a plus or minus, yes. But if it just, the square root is there, they're asking for the real answer. So the square root of 9 is 3. Does 3 equal negative 3? No, so negative 1 does not work. But you guys have to check.
So for the answer, like on the test, we just cross it out?
You can just cross it out. Yes. Let's scoot on over to 4. How many radicals do you see? 1. All right, I keep asking the same question. You'll see why in the next slide. So I'm going to circle that radical. Is the radical by itself? No. So what should I do? Let's add 1. Perfect. So now I have the square root of 6x plus 7 equals x plus 1. Now we're back at the exact same place we were in problem 3. Yep. I should probably add correctly, right? We're at the same spot that we just were. My radical is isolated, yeah? So what do I do to both sides? We're going to square both sides. Great. So I have 6x plus 7 equals x plus 2 quantity squared. That's x plus 2 times what? X plus 2. Good. So it's x squared plus 4x plus 4. You guys good? Here we are. Back to a quadratic. Get everything to one side and then factor. So minus 6x minus 7 from both sides. X squared minus 2x minus 3 equals 0. Is anybody having deja vu? It's the exact same thing we just had, all right? Can we factor that? Yeah, we factored it 3 or 4 minutes ago. What is this? Perfect. X minus 3x plus 1. So my 2x values are positive 3 and negative 1, correct? And then what do we have to do? We got to check it, all right? We're doing the exact same thing every single time. So I have 6 times 3 plus 7 minus 1 on the outside there equals, what is x plus 1? So 3 plus 1. 6 times 3. 18 plus 7 is? Yep. What's the square root of 25? 5, and 5 minus 1 is? 4. Does 4 equal 4? Yep, 3 works. Should I just go ahead and cross off negative 1? Sure, that's what some of you are going to do. Let's check it. So I'm going to plug in negative 1. So 6 times negative 1 plus 7. And then I have that minus 1 out here. And then negative 1 plus 1. What's 6 times negative 1? Negative 6. Negative 6 plus 7 is? So square root of 1 minus 1. Does that equal 0? What's the square root of 1? What's 1 minus 1? Does 0 equal 0? So what do you know about x equals negative 1? It works too. Don't just assume something doesn't work. You cannot just say, oh, the first one I tried works, so the second one doesn't. That's not always the case. You have to check. Okay? All right. The next 2 examples I'm going to do on the video right now with you guys in class are 5 and 7. Then I'm going to finish. You guys have questions on your homework. You can ask me from 1.6a. But then on the video, before I upload it, I will do the last 2. Just so you guys, they're just 2 different types, so I just want you to see them. How is number 5 different from the ones we've been doing? There's 2 radicals where? On the same side. Okay, you can't just square both sides like it is. It becomes an absolute disaster if you try to do that. You cannot do that. So when you have 2 radicals on the same side, we have to move one to the other side. Doesn't matter which one, but you have to move one to the other side. You have to. Then once you have them on the either side, we're going to do the same thing we've been doing. But you notice now we have 2 radicals. They're not the same. You can't combine them or anything like that. So I'm going to take this one, and I'm going to move it over here. It is negative, correct? So when I move it to the other side, it becomes what? Plus, okay? So I have 2x plus 3 equals, and you can write it however you want, 1 plus or x plus, square root of x plus 1 plus 1, however you want to write it. But now that you have them on either side, our goal is to get one radical and then isolate it. So how are we going to do that? Now you can square both sides. And now, correct. Very good. You're going to square the whole thing because you have a binomial. And the reason that we do this, I'm sorry, guys. This side is just 2x plus 3. Over here, this is the binomial 1 plus the square root of x plus 1 times 1 plus the square root of x plus 1. Now, this is real algebra heavy, guys. But this isn't anything crazy. It's just algebra. Yes, sir. So leave your 2x plus 3 alone. And let's FOIL, guys. Your FOILing does not change. First times first. What's 1 times 1? 1. What is 1 times this radical? That radical, okay? So I have plus square root of x plus 1. What is that radical times 1? That radical, again, so I have another square root of x plus 1. And then what happens when I multiply the same radical by itself? It just, the radicals cancel, so you have plus x plus 1. Now, the reason that we did this, guys, was to get one radical, and then we can isolate it, which we have now done. I'm still leaving 2x plus 3 over here, still hanging out. What can I combine? Well, I have a positive 1 here, and I have a positive 1 here, so that gives me what? 2. I have this plain old x just hanging out over here, so I could say plus x. And how many of these radicals do I have? So I have plus 2 square root of x plus 1. This is one term. This is together. It stays together like that. Do I now have one radical that I can isolate? Yes. What do I do with the 2 and the x? I'm going to subtract it. I'm going to move it to the other side. So minus 2 minus x. So I have 2x minus x is x. 3 minus 2 is plus 1 equals 2 times the square root of x plus 1. And now this is a problem that we started off with 15 minutes ago. Is my radical completely isolated? No. So what do? Divide both sides by 2. Because you want to get your radical by itself. I'm going to rewrite it, guys, just so the radical's on the left, just because that's how I like it. So x plus 1, square root of x plus 1, and then I have x plus 1 divided by 2. How do I get my radical all by itself? I'm going to square. I'm going to square both sides. What you do to one side, you do to the other. So when you square a square root, it just cancels. X plus 1. Where does that 2 go? To everything. Yeah. No. We're squaring both sides. So this becomes x plus 1 times x plus 1 in the numerator over what? Over 4. Because the 2 goes here and it goes down here. So I have x plus 1 on my left-hand side, and I'm going to FOIL. X squared plus what? 2x plus 1 over 4. Couple different ways from here you can solve. What are some things I could do? Okay, common denominator would be what? You can multiply everything by 4. Good. What else can we do? You just cross multiply. Perfect. So I'm just going to cross multiply. And any of those options that you guys just said are perfectly fine. Cross multiply here. And we're back at the same spot. We're back at the same spot we were in all the other problems. You're always going to get back to this spot where it becomes a quadratic. Get everything to one side. Factor. So this is x squared plus 2x plus 1 equals 4x plus 4. God bless. Subtract 4x and 4 from both sides. X squared minus 2x minus 3 equals 0. Seriously? The last 3 problems were exactly the same. Crazy. Guys, I think we can factor this one. What were the factors the last 2 times we did this? X minus 3 and... Nope, nothing was out there. So x equals negative 3 and x equals positive 3 and x equals negative 1. Ay, ay, ay. Do you think we can give you like 5 of those on a test? No.
When you check your answer,
We're going to check.
can you only check on like the first step, like in the beginning?
I would always check from the very beginning, because if you made a mistake somewhere in your math and you check there, like your wrong answer will follow where you made the mistake. You know what I mean? So I would go back to the very original. That's a good question. So what were the 2 numbers we got? I forgot. Positive 3 and negative 1. So let's check real quick. X equals 3 and x equals -1. So 2 times 3 plus 3 minus 3 plus 1 equals 1. Okay, so 2 times 3 is 6, and 6 plus 3 is 9. So square root of 9 minus 3 plus 1 is 4. Square root of 9 is 3, minus square root of 4 is 2, equals 1. 1 equals 1. Ooh, what do we know about that then? Okay, it's true. Works. Good. All right, same thing. I have 2 times -1 plus 3 minus -1 plus 1. Does it equal 1? 2 times -1. -2 plus 3 is 1. Minus, what's -1 plus 1? 0. What's the square root of 0? What's the square root of 1? So 1 minus 0 equals 1. 1 equals 1. So then this one works too. Yeah.
Will there be a case where both don't work and there's no solution?
Always keep the possibility of no solution. That's why it's so important to really pay attention to signs and stuff like that. Because you miss a sign, you know, if you said x was 1 instead of +1, you would plug it in and it wouldn't work. And then you'd say, oh, this one's no solution. When it's really not no solution, we just made a sign error. So you just got to be careful. All right, the last one I want to do is 7. 7's a little different. And again, I will do, what did I do, 5? I will do 6 and 8 at the end of this video. So when I post it, it's there. I don't want to rush too much. Okay, this is the exact same setup as the last one, correct? But what do you notice? I have 2 radicals, but they're on opposite sides now. I don't have to worry about moving anything. So what should my first step be to do here? Square both sides, okay? The whole quantity, you're going to square both sides. So this is really the square root of x plus 5 minus 2 times the square root of x plus 5 minus 2 equals just x minus 1, right? So algebra, the same square root times the same square root. What happens? Just cancels. It's just x plus 5. Good. So I have the square root of x plus 5 times -2. -2 times square root of x plus 5. Then I have what? -2. Again, I have another -2 square root of x plus 5. And then -2 and -2 is +4. Good. So let's talk about what we can combine. These are going to stay together. So I have a positive x. So I have x. I have a positive 5 and a positive 4 gives me 9. Thanks. And, whoops. And then how many x square root of x minus 5s do I have? What kind? Both negative. Good. I have -2 and -2. I have -4 of square root of x minus 5 equals x minus 1. So what was our goal? Our goal was to have only one radical, and we need to isolate it, correct? So there is my one radical, and I'm going to isolate. So what should I do first with my x and my 9? Subtract them both. Good. So subtract x, subtract 9. Subtract x, subtract 9. So x cancels. So I have -4 times the square root of x plus 5 equals -10. My x canceled. Is that okay? Yes. How many answers are we going to have here, guys? We're only going to have one. All right, we don't have anything x squared. We don't have a quadratic, so this is just going to end up where you only have one answer. That's fine. I need to get my radical by itself. What do? Divide both sides by -4. Do not turn this into a decimal. Just simplify the fraction. What's -10 divided by -4? 5/2. Good. And then what's our last step? Square both sides. So when I square my square root, it just cancels. So I have x plus 5 equals what? 25/4. Then my last step. Subtract the 5. I'm going to go ahead and turn 5 into fourths, which would be what? 20. So 20/4. What's 25/4 minus 20/4? 5/4. And what should I do with that? You guys are like, oh my God, seriously. What do we have to do, guys, on all of these problems? Check, all right? On the ones from 1.6a, some of them said solve and then check for extraneous. What you had to do there, you're not going to get an extraneous solution if you just have x to the fourth, x squared, whatever. When you'll have solutions that don't work, it would be when you have radicals. It would also be when you have denominators that have variables in them. That's when you really have to go back and check just to make sure. But if you don't have those two things, then you should be fine. All right, number 6, guys, we have the same problem where we have 2 square roots on one side. So we need to move one of them to the other side. So I'm just going to take this and move it over here. If you see this is negative, so when I move it to the other side, it becomes positive. So over here we have square root of 2x minus 5 equals, and on the right-hand side I have 1 plus the square root of x minus 3. And now that we have the square roots on opposite sides, we can go ahead and square both sides. Because, again, we're trying to get one radical by itself, and then we'll isolate it. So when you square square root, this just becomes 2x minus 5 equals, this is 1 plus square root of x minus 3 times 1 plus the square root of x minus 3. So we're going to leave our 2x minus 5 hanging out over here. And then we're going to FOIL. 1 times 1 is 1. 1 times radical x minus 3 is just plus square root of x minus 3. Then the square root of x minus 3 times 1 is another square root of x minus 3. And then the square root of x minus 3 times the square root of x minus 3 is just going to take away the square roots. They cancel out, so you have x minus 3. And then what can we combine? I have a 1 here and a negative 3, which gives me negative 2. And then I have that x, and then I have 2 of these, so plus 2 square roots of x minus 3. And then over here I have 2x minus 5. So now we can go ahead and isolate this radical right here. So I'm going to add 2 and subtract x. So add 2 and subtract x. That leaves me with x minus 3 equals 2 times the square root of x minus 3. So we have our one radical, which we're just trying to get by itself. We're going to isolate it. So I'm going to rewrite the radical on the left-hand side. So square root of x minus 3 equals x minus 3 over 2. And from this point, we can now square both sides and solve. So square this side, square this side. So you have x minus 3 equals, this will be x minus 3 squared on top. And then 2 squared is 4 on the bottom. So go ahead and FOIL. Over here on the left you have x minus 3 equals, on the right we have x squared minus 6x plus 9 over 4. And then I'm going to go ahead and cross multiply. So x squared minus 6x plus 9 equals 4 times x minus 3. Distribute. X squared minus 6x plus 9 equals 4x minus 12. And then we're going to get everything on one side. So minus 4x from both sides and plus 12. So x squared minus 10x plus 21 equals 0. And the last thing we're going to do is factor. What are the factors of 21 that multiply to give you positive 21 but add to give you negative 10? That would be minus 7 and minus 3. So you get x equals 7 and x equals 3. And what do we need to do with those two answers, guys? We got to make sure we go back and check. So let's check here. We have 2 times 7 minus 5. And then underneath this radical is 7 minus 3. Does that equal 1? Well, 14 minus 5 is 9. So square root of 9 minus the square root of 4 equals 1. Square root of 9 is 3 minus 2 equals 1. So yes, x equals 7 works. And same thing, we're going to plug in 3. So square roots of 2 times 3 minus 5 minus the square root of 3 minus 3 equals 1. 6 minus 5 square root of 1 minus the square root of 0 equals 1. Square root of 1 is 1 minus 0 equals 1. Yes, that's true. So x equals 3 is a solution as well. And now moving over to number 8. All right, number 8 is already set up for us like we need it to be with our radicals on either side. So from this point, we can go ahead and just square both sides. So over here, I'm left with 4x plus 1, because when you square root, it cancels. And then over here, I have two binomials, square root of x plus 1, sorry, x minus 1. X minus 1 plus 2 times the square root of x minus 1 plus 2. So now we're going to FOIL. Square root of x minus 1 times square root of x minus 1 is just going to be x minus 1. Here to here is going to give me plus 2 square root of x minus 1 plus another 2 square root of x minus 1, and then 2 times 2 is 4. So we combine like terms here. I have x, I have a negative 1 and a positive 4, gives me plus 3. I have 2 square roots here and 2 here, gives me plus 4, square root of x minus 1. And then over here on the side, I have my 4x plus 1. So we now have our radical exactly how we want it. We need to go ahead and get our numbers to one side, letters to another, or try to isolate that radical first. So minus x, we're going to minus 3, minus 3. So 4x minus 3x, 4x minus 1x is 3x. Positive 1 and a negative 3 is minus 2. Equals 4 times the square root of x minus 1. Our radical is almost by itself now. We're just going to have to divide both sides by 4. So I'm going to rewrite the radical on the left here. So I have square root of x minus 1 equals 3x minus 2 over 4. Now that we have our radical isolated, we need to get rid of it, so we're going to square both sides. So you have x minus 1 equals, this would be 3x minus 2 times 3x minus 2 in your numerator over 4 times 4 is 16, because that 2 goes to both the numerator and the denominator. So now we have x minus 1 equals 3x times 3x is 9x squared. 3x times negative 2, and the negative 2 and 3x is going to give me negative 12x. Negative 2 and negative 2 is positive 4 over 16. So now we can do one of two things. You can multiply both sides by 16, cross multiply, whatever you want to do. I'm going to go ahead and cross multiply. So 9x squared minus 12x plus 4 equals 16 times x minus 1. 9x squared minus 12x plus 4 equals 16x minus 16. Now I'm going to subtract my 16x, and I'm going to add 16. And I get 9x squared minus 28x plus 20 equals 0. And then this just becomes a factoring problem that we have done a million times. So we're going to multiply a times c. So 9 times 20 is 180. So I need factors of 180 that multiply to give me 180 but add to give me negative 28. That's going to be negative 18 and negative 10. I'm going to go ahead and do the grouping method. So 9x squared minus 18x minus 10x plus 20 equals 0. Group the first 2 and the second 2. I can take out a 9x, and I'm left with x minus 2. Over here, I can take out a negative 10, and I'm left with x minus 2. So I have x minus 2 times 9x minus 10 equals 0. So I get my two solutions of x equals 2 and x equals 10 over 9. And you need to go back and check and make sure that those both work.